Hello. So in this video, I will be discussing Codeforces around 998 rated for division 3. So I will be discussing first 5 problems of this set. Let's start with problem number A, that is Fibonacci's. So in this question, we are given total 5 integers 1, 2, 4 and 5. And there is an integer number 3 which is missing from it. Now what we can do, we can add any number as integer 3 in this sequence. Now, after adding that number 3, there should be a score. And what is the score? The score is the Fibonacci's array. Like, what is a Fibonacci number? Fibonacci is a number which is the sum of its previous two number. Like a of I plus 2 is the sum of a of I plus a of I plus 1. So adding that number 3, tell me how many number of pairs would be there in your array, right? So that will be your final answer. So you can add any number 3 in the array, right? So how to solve this problem? So this is a very easy problem. Let me tell you how. So let me just simply show the code only. So uh, like I have total 3 integers like a b, and let's suppose z is a number which I have to add, and c and d. So according to the question, my a plus b should be equal to z, my b plus z should be equal to c, and my z plus c should be equal to d, right? So I'll check this. If my a plus b is equal to c minus b, which means these two z are will be equal, right? So I will simply check if there exists a z such that a plus b is equal to c minus b, and that is also equal to d minus c. If these three conditions satisfy, which means there is a common z which will be satisfying both of the three conditions, then in that case my answer will be 3. But if it is not the case, then I will just simply try to check whether my two conditions are satisfying or not, whether my a plus b is equal to c minus b, or my c minus b is equal to d minus c, or my a plus b equal to d minus c. If any of these conditions is satisfied, then my answer is 2. Else I know one, my answer, I can always get answer as 1. So I will just simply print 1 as my answer. So yeah, this is problem number A. Let's now discuss problem number B, that is Farmer Jones card game. Okay, so this is also a very easy problem, I can say. So there are total n cows, okay, and each and every cow is given m number of cards. Okay, done. And there are total n into m cards in the game. Okay, hopes we got it how. And each and every card has a different number starting from 0 to n into m minus 1. Okay, done. Now what Farmer John said to you, like he will select a permutation. Okay, he will select a permutation, and for example, in the permutation, my first number is 3. Okay, I'll explain it here. So let's suppose in my permutation, first number is 3, second is 2, next is 1, and let's suppose it is 0, and let's suppose it is 4. Okay, done. Now this is a permutation of 4 numbers, right? Till 4 numbers. Now my first number is 3. Okay, done. Now what we'll do, Farmer John will select cow at number 3. Okay, cow at number 3. Now cow at number 3 will select the cards from his deck and put it on a pile. Okay, done. Now whose turn is now? Cow 2 will take a turn. Now what cow 2 will take? Cow 2 will choose a card from her deck and put it on the pile of the cards. Okay, done. Now similarly the sequence will repeat until each and every cow exhausted her cards. But there is a condition. If my previous cow put a number, let's suppose x, then my next cow will should has to put a number x plus 1, right? Or number which is greater than x. Okay. If the cow is not able to put a number which is greater than x, then that cow will lose. Okay, now what Farmer Jones want? He wants all of the cows to win. Okay, now what permutation should be selected says that all of the cow wins. Okay, so pretty interesting problem, right? But how to solve it? I'll just give you explanation. I will give you an explanation. Okay, let me distribute the numbers. For example, I have total 3 cows. Okay, and I will distribute the numbers randomly. Like 0 card is here, 1 card is here, 2 is here, 3 is here, let's suppose 4 is here, 5 is here, 6 is here, and 7 is here, and 8 is here. Okay, done. Now how I will generate a permutation. Okay, done. First of all, I'll create a map for each and every card. Like which card is with which cow. This is cow number 1, this is cow number 2, this is cow number 3. Okay, done. And I also know total I have 0 to n into m minus 1 cows, right? So in this case I have total 8 cows, 8 cards. So selecting from card number 0, my card number 0 is which cow? My card number 0 is which is with cow number 1. Okay, I'll write my 1 over here. This is the place where I'm generating permutation. Now tell me, if the same card, if the same, if the next card, let's suppose the next card is 1, right? If next card is with the same cow, okay, if next card is with the same cow, can there will be a valid permutation or not? The answer is no, because in any case, in like if you take any case, at then this cow will be left and this cow will lose, right? So there is one more condition, that consecutive numbers should be with different cows. Okay, done. So one is with her. Then now I'll check for one. One is with two cow. Okay, done. Now my next card is with cow number 1 again. Okay, my cow number 1 again. Okay, done. Now my next card is with, okay, I'll check. Now my next card is with cow number 2 again. Okay, I'll write 2 over here. Now my next card is with cow number 3. Okay, done. Now cow number 3 is also done. Now you can see my a sequence is generated over here, right? A sequence is generated over here. Now I will repeat this particular sequence. I'll repeat this particular sequence and check whether I can win or not. Okay, whether I can win or not. If I show you the code is also easy. Now first of all I'll take a map. Okay, map will first of the integer will contain the card number. Second will contain the index whom my card is having. Okay, the card, the I think so this is the same question. Yeah, this is the right question. So I'll create a map. Uh, first element will represent the card number. The set will uh, the set will gen- the set will represent whom I am having the card with, right? So I'll take the input the card and insert that this card is with this cow. Okay, done. Okay, done. Now what I'll do, I will just run a loop from 0 to n minus 1 and check where my current card is present at. Okay, I'll check the location. Location is just simply representing the cow number. Okay, this is the location. I'll erase it. Okay, done. Just for memory cleanage. And what I'll do next, I'll check if my answer size, if there's an answer size and my answer of back is also equal to location. This is a place where I'm checking whether the same cow is having consecutive numbers, right? So my I is a I will be consecutive, right? If the location is same for both of the numbers, then I'll return -1, because same card cannot be with same cow, right? I'll just simply return -1. Else what I'll do, in my answer I'll just insert a location. Okay, done. If at any point, if at any point my answer dot size is equal to my number of cows. Okay, if at any point my number of if my size of my answer is equal to number of cow, I'll just track my last number. Okay, what is the last number? Because I know at this point my number of cards are done. Okay, I have submitted this number of cards. I'll just simply break. Okay, done. Now there are two cases. If my all of the cards are done. Okay, if my all of the cards are done, then I'll not loop this one, because I'm starting from last number plus one. If my last one is originally n into n minus one, then I'll not come in this loop and just simply put the answer. Okay, done. But if it is not the case, but if it's not the case, then I'll just simply check the pending numbers. Okay, and there's one more case. You know one thing, that my permutation is already been created. I'll confirm my dead permutation only, because from I plus 1 to n into m, my this condition should satisfy the permutation which I've created earlier. That permutation should only be carried forward to other cases. You can see, I'll check the index from the 0 and find the location. Okay, if my location is not equal to my index of 0, because at this point I am at the last point. Now if my permutation ends, I'll again start from the 0th permutation, right? This is the question saying, right? So if my fourth number of cow is done, then again first number of cow will take the turn, right? So that's why I'm checking from index 0. Okay, if it is not equal to my current index, then I'll just simply put -1 return. Else I'll just increase my index, and if it is increasing my array, I'll make it again to set to 0. And if all my conditions satisfy, then I'll just simply put my final permutation at then and just return it from here. Yeah. So let's now discuss problem number C, that is game of Mathletes, whatever it is. So there total n even integers on a blackboard represented by x1, x2 till xn. Okay, done. And there is also a integer k. Okay, done. And initially score is 0. Game lasts for n by 2 turns, in which the following events happen sequentially. Okay, Elias select an integer from blackboard and erase it. Let's call Elias choose integer a, and similarly Bob will choose a integer and Bob will erase it also from the blackboard, and Bob's integer will be b. If my a plus b equal to k, then I'll add 1 to my score, else I'll add 0 to my score. Okay, done. And A and B are coming from the blackboard. A is selected by Elias, B is selected by Bob. If the sum is equal to k, which is given to us initially, if I'll add 1 to my score, else I'll add 0 to my score. Now Elias want to minimize the score while Bob wants to maximize the score. So how, if the both players play optimally, what is the score at the end? So tell me, if there's Elias, there's Bob. Elias want to minimize the score while Bob wants to maximize the score, right? So what number should Elias choose such that my score is minimized? For example, my k is 8 over here. Okay, done. And my number integers are like 4, 4, 6, 2, and let's suppose 7 and 9. And let's suppose there's also number 1. But my number of integers should be even. So I will also add 3 over here. Now tell me, Bob always want to make a pair such that the sum of pair is equal to k. Now Elias always want to make a pair such that the sum of pair is not equal to k. So what Elias will do? Elias will greedily choose that number whose pair is not present in the array. Now tell me, is there a pair present for 9 or not? There is not a pair of for 9. Right, right. Now what number will Bob choose? Bob will greedily choose that number who, like for example, if Elias has chosen a pair such that there is no pair for that particular number. Okay, done. Elias chooses a number such that there is no pair for that particular number. Now Bob will greedily choose another number whose pair is also not there. But why? Because he do not want to waste the pairs whom he can get a sum of k. This is the only logic, right? So tell me another pair whose pair cannot be created. So I think so 3 is another pair whose pair cannot be created, right? So 9 and 3 are discarded. Okay, I'll go to next pair. Now tell me, now you can see all of the numbers are present in the array, their pair exists. Okay, now Elias will choose 1 over here. Okay, done. Now Bob knows there's 7. Now if I add 7 and 1, then my k will be 8, and I'll add 1 to score because Bob wants to maximize the score. Add 1. Similarly, Elias will choose 4 and Bob will choose 4. It will be sum to 8. Elias will choose 6. Bob will choose 2. It will add to 8 and just increase the answer. So the simple funda of the question is, if Elias will always choose the number whose pair is not present. Okay, done. If Elias chooses the number whose pair is not there, then Bob will also choose the number whose pair is not there, because he do not want to waste the numbers whose pair are present, right? So yeah. So yeah, if the Elias chooses a number, if there's no such pair, if there's no such number left whose pair cannot be created, then Elias will choose a number whose pair can be created, and Bob knows what number to choose next, such that the sum is equal to 8. So yeah, I'll show the answer also, solution also. So yeah, just take the input array, make a map for finding the number. Now, if my this is the first number, okay, f dot first and second number. Okay, now I know f dot first plus second is equal to k, right? Now Elias will always try to choose the number. Now what I'll do, if I just simply simply sum up the question. Now you know the total number of numbers in your question is n, right? And total number of integers whose pair cannot be created are, let's suppose, x. Okay, done. Remaining number can be created as a pair. Let's suppose it is y. Now what is the answer? Answer is y by 2. Just simply print y by 2. Number of pairs whose sum is equal to 8 is your answer. Yeah, that's a simple question. So this is the simple implementation only. I think so you can increase this part. You can just simply print the count. Yeah. So the count is simply the number of pairs whose pair exists, and I'm just printing the count. You can see the implementation. Implementation is also clear. Let's now discuss problem number D, that is subtract min sort. Okay, now what is this question asking? So their total a, we are given a number, we are given an integer array a and positive integers. Now what we can do? Okay, yeah. So we are given an integer array, and what operation we can perform? We can choose any two integer array, any two integer numbers a of I and a of I plus 1, and subtract minimum of a of I from both a of I and a of I plus 1, which means the minimum number will be set to 0 and the maximum number should be subtracted by minimum number. Now tell me whether it is possible to make the array in decreasing order or not. First of all, if this is, I'll give you a very quick explanation. If you're getting a pair like 7 comma 2 and you made an operation on this pair, you will never get your answer. But why? You know, uh, making an operation on this pair will result to 0 comma 5. Now tell me, can you make this decreasing? You cannot make this decreasing. So you will always make an operation on numbers like, if your current number is smaller than your next number, then only you will make an operation, else you will not make an operation. So just greedily run the loop from starting and check. If your current number is smaller than or equal to your next number, subtract the smaller number from the largest number, which means i plus subtract the I from I plus 1 and set I of set ith number to 0. And yeah, if it is not the case, which means your current number is greater than your previous number, yeah, if your current number is smaller than your previous number, then you cannot make your array in decreasing order, because for making operation on this such of pair will lead to never getting your answer. Yeah, just find the answer and return no in this case, else just make the subtraction and yeah, just do it. If you're able to reach the end, if you are able to reach to the end of the array, just print yes, else print no. Yeah, this is very simple problem, I think so, not a level of D maybe, but yeah. Now I'll discuss problem number 8, that is graph composition. So I'll just simply explain that what problem is asking. You are given two graphs. What are the numbers? F and G. Okay. You are given two graphs F and G. Okay, done. Now you can perform two type of operation. One type of operation is removing a edge from graph F between any two numbers or any two edges. Okay. You can remove a edge between any two vertices in a F, and what you can do, you can add edge between any two vertices in graph F. Okay. Now what this question asking you to do, the minimum number of operations required such that such that you can read this read this line carefully, such that the minimum number of operations required, that there's a path from U to V in F, if and only if there's a path from U to V in G, which means there should only be path from U to V in F if there's a path from U to V in G also. This is the only question, and the two options given to you are addition of any edge and removal of any edge in graph F, right? So how to solve this problem? So this is a very standard DSU problem, data set join. So if you don't know DSU, you can think so you can learn it before coming to video. Yeah. So yeah, I'll just tell you how you can solve this problem using DSU. So for example, I am having some number of pairs like 1, 2, 3, 4, 5, 6, 7, and 8. Okay, done. And similarly a cloud over here also, other numbers, a number cloud I can say 5, 6, 7, 1, 2, 3, 4, and 5, 6, 7, 8. Yeah. So let's suppose this is E, let's suppose this is your F, this is your G. Okay, I'll create an initial graph of G. Let's suppose it is 1, it is connected, it is connected, it is connected, and they're connected. Okay, done. And similarly these two are connected, and in this particular graph F, I'm just making a random connections over here. And yeah, let's suppose this is my F and this is my G. Now how I will justify my question? First of all, I'll create a disjoint set union of my graph G. Okay, then, which will let me know whether my two edges are connected or not, whether my two vertices lies in the same component or not. Okay, So at then, okay, let me just justify one more thing. At the end, what I will try to do, I'll try to make a component uh, in F similar to G, which means in my G, if 1, 4, 7 and 8 are connected, I will try to connect 1, 4, 7 and 8 in F also. If there should be no other edge connected to this particular component in F also. Okay, if my 2 is solo, then in my F, my 2 should also be solo. If my 5 and 3 are connected in G, then 5 and 3 should also be connected in F, and no other edge should be present with respect to 5 or 3 except in between them. Okay, hope you got the point. If there are 4 components in G, there should be 4 components in F, and configuration of each and every component should be same, which means the number of participant and the number on the participant should be same in the number of participant on the F also. Okay, right. But how to proceed with it? I'll just be greedy in this problem also. But how to be greedy? First of all, uh, I'll just break the points which are not connected in G. Okay, I'll just run a loop. For example, if I just justify what are the edges connected in this question, my connected edges are 1 and 8. Okay, and 8 and 3, 3 and 2, 5, 4 and 7, 7 and 5, and yeah, 6 is connected to nowhere. Okay, done. Now what I will do, I'll just check whether my 1 and 8 are connected in G or not. Yes, my 1 and 8 are belong to the same component. Okay, done. This will pass. Okay, now at this point I have created a disjoint set of only G, not for F. Okay, I'll tell you later but why. So at this point I have created a disjoint set union for G but not for F. Okay, done. Now whether my 1 and 8 are connected in G or not, they are connected. So it will pass. Now tell me whether my, okay, 3 is missing over here. Okay, yeah, 3 is here. Now tell me whether my 8 and 3 are connected in G or not. No, they are not connected. So I will just erase this thing. I'll just erase this edge. Okay, done. And add my now increase my removal to +1. Okay, I'll just make a counter over here. Removal is equal to 1. Now my 3 are 2 connected in G or not? 3 or 2 are not connected. I'll just move it and increase my removal to 2. Okay, done. Now tell me my 4 and 7 are connected. Yes, my 4 and 7 are connected, which means they are also passing. Okay, they also pass. Are my 7 and 5 connected? No, my 7 and 5 are not connected. So I'll just erase it and my removal count is now increased to 3. Now total number of 3 removals are required to me. Okay, done. Now total number of 3 removals are required to me initially. Okay, done. Now. Initially, what I have done, I have only created a graph of G. Now what I will do, I will now create a disjoint set union graph for F also. Okay, done. How does it will look like? Now you know, my 8 and 3, there is no edge between them. 3 and 2, there is no edge between them. 7 and 5, there is no edge between them. Okay, done. Done. Now what I will do next? Now this is my initial set. Now what I will do, I'll run a loop in my graph G. Now tell me what are the connected points. The graph of my G look like 1 4. Okay, 4 7. Okay, done. This is the input array which I'm getting, just writing it simply. 7 and 8 and 1 and 8, 5 and 3. Okay, done. Now I'll run a loop. Whether my 1 and 4 are connected in this or not. No, they are not connected. So I'll just connect them. Okay, done. And let's suppose this is my addition count. It is initially 1. Okay, done. Okay, I have connected it. My 4 and 7 are connected or not? Yes, my 4 and 7 are already connected. So yeah, it is also done. 7 and 8 are connected or not? Okay, I think so I have missed it. Okay, yeah. 1 and 4 are connected in G or not? Yeah, they are connected. I'll connect it over there also. So my addition count has increased to 1. Whether my 4 and 7 are connected? Yes, 4 and 7 are connected. So now in F also they are connected. So no need to add, no need to increase addition. My 7 or 8 are connected or not? Yes, they are connected, but here they are not connected. No, here they are also connected. You can see 7 and 8 are belong to same component, right? So yeah, no need to increase it. whether whether my 1 and 8 are connected. 1 and 8 are also connected, so yeah, just do it. Whether my 5 or 3 are connected, 5 or 3 are not connected, so I'll just increase my add to 2 and make it a connection between 5 and 3. Now tell me, what is the answer is movable count plus addition count, that is 5. So yeah, this is the whole implementation. I'll show you the code is also easy. First of all, I'll declare two disjoint set, but I'll only connect my disjoint set of graph G. You can notice over here, I'm not making a disjoint set for my uh, uh, f f graph, because I have to make removals also. After making the removals, I'll make the final graph and make further additions based on the G only. Okay, so initially I have taken input graph of A and A1 and A2 and make the disjoint set union for only G. Okay, done. I'll run a loop of I'll run a loop on A1 and check whether this is a connected component in my G or not. If it is a connected component, if it is a connected component, I'll connect in my I'll connect in my initial graph also and just continue. Else, okay. Else what I'll do? Okay, this is else case. If if these 2 points are connected in my F but not in G, because I'll get to know G. I'll get to know for the G by disjoint set which I've created in while taking the input only. So yeah, if they are not connected in my G graph, then I'll just set it to 0, because 0 is no vertex in your array. So at then it does not matter, but where, if they are 0, it does not matter while taking off the set. So yeah, so for each and every removal, I'm not adding in it, I'm not adding in my DSO. But if they are not, but yeah, if they are not connected, I'll just make it 0. Okay, done. Now I'll run a loop on A2. Okay, done. So if my point which are present in my G graph, if the connection which are present in my G graph are also present in my F graph, then I'll continue. Else I'll make a connection between them and increase the counting of add plus plus and here remove plus plus, because at this point this is a this is the edge which needs to remove from F, and which was also not in G, right? Which is in F and not in G. So add then just simply return add plus remove. So this is the explanation of first 5 problems of this problem set. If you have any doubts, please do ask me in the comment section, and you will get the code in comment section. And till then, stay tuned for the next one. Thanks.